In today's lesson, we're going to learn how to solve multi-step equations. There are 4 steps to solving these, and they are as follows. First and foremost, if we have any parentheses where a number is multiplied in front of it, we want to make sure to distribute that number to every single term, multiplying it to every single term in the parentheses. The second step we want to do is combine like terms on the same side of the equal sign. Like terms are going to be our x variables with our x variables, and then our numbers with our numbers, our constants with our constants. Then we go ahead and move any variables to one side. That way we're balancing or canceling out the variable on the other side. Last but not least, we'll use those inverse, also known as opposite operations: addition, subtraction, multiplication, division. Let's go ahead and use those steps for example A here. There are no parentheses, so I'm going to go ahead and move to step number 2, which is combine like terms on the same side. Well, if I take a look, I'll highlight my y variable terms. They're on opposite sides, and then my constant number terms are on opposite sides as well. I have to now balance this out by moving the variables to one side. So I'll move that 3y over with subtraction. That's the only way I'll get it to cancel out on this right side. The only way to cancel out 3y is to subtract a 3y, making 0 with the plus 12 left on the right side. On the left side, the negative 8 wasn't touched, so I'll just bring that down just like I did the 12. And then I have 5y minus 2y. They're like variables, so we just subtract their coefficients. 5 minus 3 is 2y left. Now I got to move over the numbers. Still need to get my variable all alone on one side, and it's 2y minus 8. So I'll have to do the opposite of subtraction, which is addition. Negative 8 plus 8 cancels out to 0. That's when I know I successfully canceled out and balanced my equation, moving my numbers to the other side, keeping my 2y on the left. 12 plus 8 comes out to be 20 on my right side. Variables are on one side, numbers on the other. Remember, when you have a 2y, it's really 2 times y. There is multiplication between the two, it's just not written. So the opposite of multiplication is my division. I will divide each side by 2 because what I do to one side, I have to do the other. 2 divided by 2 is 1y left, and 20 divided by 2 is 10 left. That will be my final answer for this variable of y here. Example B, we have negative 6 plus 14 equals 12 minus 8. So again, I want to distribute if I have any parentheses, which I do not. Then I want to combine like terms on the same side. Well, my like terms of the negative 6x and negative 8x are on opposite sides. Same thing with my numbers of 14 and 12. Have to move the variable to one side. I will go ahead and add 8x over, combining it with that negative 6x. Negative 8x plus 8x cancels out to be 0. I know I did that correctly when I do that math, and it cancels out, moving that 8x to the left side, keeping 12 all alone on that right side. Negative 6 plus 8x comes out to be 2x, and then we add 14. From here, got to combine my numbers together. It's a plus 14, so I have to do the opposite subtraction. That's the only way I'll cancel out and move the 14 to the other side. 14 minus 14 comes out to be 0. Perfect. I moved down the 2x I did nothing with. And then equal my right side to 12 minus 14, which is negative 2. From here, it is 2 multiply to that x, so we do the opposite of multiplication, division on each side. 2 divided by 2 is 1x left. Negative 2 divided by 2 is negative 1 left on the right there. In the next example C, I have 7k equals 3k minus 36. So I look at my like terms and make sure I combine them, moving my variable to one side. In order to combine the 3k on the opposite side of the 7k, I will have to subtract it from each side. That's the only way 3k will be moved over to 7k. 3k minus 3k cancels out to 0, and I'm left with that negative 36 here on my right side. On the left side, I have 7k minus 3k, which is 4k. Remember, it's 4 times k, so we have to do the opposite of multiplication, which is division, on each side. 4 divided by 4 is 1k left on the left side. On the right side, negative 36 divided by 4 is negative 9. In the next example, example D, we have those parentheses we were talking about earlier with this negative 7 multiplied to the outside. So with negative 7 multiplied to the outside, I must distribute negative 7 to both terms in my parentheses here. I have two terms, that 3a, which is a variable, and that negative 1, which is a number, but I'll need to multiply negative 7 to both of them. So I keep 91 on my left side. I'm not going to do anything with that yet because I have to do the parentheses first. Have to distribute negative 7 times 3a, multiply the two numbers, which will make negative 21, and then I have my variable a left. Negative 7 times negative 1 will come out to be a positive 7. Two negatives make a positive there. Now, I have one variable term, but I still want to get a by itself, so I can't combine with a variable with anything yet. What I can combine is my 7 with 91. To move 7 over, I do the opposite of addition, which is subtraction. That way, plus 7 minus 7 comes out to be 0. I'm left with negative 21a on my right side. 91 minus 7 gives me 84. It's negative 21 times a, so I do the opposite of multiplication, which is division. When I divide by negative 21, I have to do it on each side. Negative 21 divided by negative 21 comes out to be 1a left. And then 84 divided by negative 21 comes out to be a negative 4. In my next example, example E, I have those parentheses again, so I must multiply this negative 5 in front of the parentheses to both terms in the parentheses, my 3m variable term and my plus 10 number term. When I distribute, it's always multiplication here, so keep the 4m as is. Not doing anything with that yet. Then keep and multiply negative 5 times 3m, which would multiply negative 5 times 3 to be negative 15. And don't forget that you had an m with it as well. Then we'll multiply negative 5 times 10, which will come out to be negative 50. Leave the 26 over here on the right side alone because we did not do anything with the 126 there. From here, I have variables on the same side. I can just combine them as is right next to each other. 4m minus 15m, which is negative 11m. I keep the negative 50 and the 126 on the right side the same. I didn't do anything with it. From here, all my variables are combined, so I look to my numbers. I look to how can I combine negative 50 and 126 on the same side, specifically moving the number next to my variable away because our goal is to always get the variable by itself. So I have to move what's next to it. The 50, in order to move it to the right side, I'll have to add it to both sides here. Negative 50 plus 50 cancels out to be 0. I did that correctly, leaving me with negative 11m, getting me so close to getting m by itself. And then on the right side, I get 176. From here, it's negative 11 times m. Do the opposite of multiplication, which is division on each side. When I divide negative 11 by negative 11, I get my answer to be m equals 16. And that would be a negative 16 because a positive and a negative make a negative there. For the last example, example F, I have two sets of parentheses. So I'll want to distribute the negative 3 to both terms in the parentheses. I'll also want to distribute what is in front of my second parentheses, which is a negative 1. Anytime you have a negative in front of the parentheses, it's really a negative 1. I'll have to distribute to both k and a positive 5. So we'll go ahead and do those distributions first. Negative 3 times k comes out to be a negative 3k. And then negative 3 times negative 8 comes out to be a positive 24. Negative 1 times k is going to be a negative k. And negative 1 times a positive 5 is negative 5. From here, that equals my 23 on the right side. I want to combine my variables and numbers on the same side of that equal sign. So on the left side of my equal sign, I have negative 3k and negative k. I combine those two together. Negative 3k minus 1k is going to be negative 4k in total when I'm combining them. I still have plus 24 minus 5 that I didn't do anything with, and I also didn't do anything with the 23 on my right side. From here, I can combine the numbers. They're next to each other on the same side of the equation, so I go ahead and combine them. And positive 24 minus 5 comes out to be 19. Negative 4k I didn't do anything with. That was a positive 19, so I put a plus a positive in front of it. And then didn't do anything with my equals 23 yet. Now, I need to get k all by itself. So it's negative 4 times k plus 19. Go in reverse PEMDAS order, meaning that I will move over my addition and subtraction first. Negative 19, negative 19 on both sides. That's the only way that positive 19 will cancel out to 0 on the right side, the left side there, giving me just the negative 4k being brought down. And then I have 23 minus 19, which is going to be a positive 4. It's negative 4k, so I do the opposite of multiplication there because it's negative 4 times k. I'll do the opposite, which is division of negative 4. Negative 4 divided by negative 4 is a positive 1k. What I do to one side, I have to do to the other, so I will now do 4 divided by negative 4, making negative 1.
Now we're going to look at two types of solution. One is called no solution and one is called infinite solutions. We're going to start the same way by drawing our line where the equal sign is and distributing the negative 4 to the 2x and the positive 1 inside. Distributing requires multiplication, so that's negative 4 times 2, which is negative 8 with an x. And then I do negative 4 times 1, which is negative 4. I'm going to bring down just everything I have on the right side. Remember, I like to have the variables here, negative x, negative 8x, and then I have a number of negative 4. Looking for like terms, there's none on the same side, so I'll have to do the opposite operation here. And you could choose which ones you combine first. I'm going to go ahead and add the x's together. Because it's a negative 8x, I'll have to plus 8x on each side. Negative 8 plus 8 cancels out to 0x left, and I bring down my number of negative 4 on the left side. Negative 8 plus 8x also cancels out to 0, so that's different than before. And now I bring down my number left, which is a negative 2. When both sides have the x's turn out to 0x left, you have a special type of solution. We call this no solution because there's no way that negative 4 is equal to negative 2. When they're not the same number, we say no solution here. At the bottom, I'll just read that there is no possible number that could work as a solution to this equation. That's why we call it no solution. For infinite solutions, let's start the same way by drawing our line here and distributing the 3. 3 goes to 1 and to negative 3x, and distribution requires multiplication. 3 times 1 is 3, and 3 times negative 3x is a negative 9 with x. I'll bring down the negative 8 from the problem, as well as my negative 5 and negative 9x I haven't done anything with yet. Again, going to look at my like terms here. I'll highlight everything that has a letter X in pink and everything that's just a number in green here. I have 2 greens on the right side, so I can go ahead and combine them just with the operation of what they have on each of those numbers. So that's 3 minus 8, changing no signs. 3 minus 8 is negative 5. I'll bring down the negative 9x that I still have, and I'll leave the left side as is, which is negative 5 minus 9x. Now that I don't have any like terms on the same side, I'll have to do the opposite side. So again, I can move either one first, but I'll move the x's together. I'll have to do the opposite of negative 9x, which is plus 9x. Negative 9x plus 9x cancels out to 0x. No x's left on that side, but I bring down the number of negative 5. On the right side, 9x minus 9x also cancels out to 0x. Bring down the number on that side. Again, I have a special case. I know it because I have no x's left in the problem. Now I see that I have negative 5 equaling to negative 5. That's a true statement. That actually is equal here. So that's why it's infinite solutions instead of no solutions. And that's what I'll write as my answer. What that means, I'll read at the bottom, is that every number could work as a solution. Okay, let's try to practice some of these. In example A, again, I'm going to go ahead and start by distributing when I have a number in front of my parentheses. Distribution requires multiplication, so 3 times 2 is 6 with x, and then 3 times 2 is 6. I'll bring down the negative 3x on that same left side, and I'll bring down the right side because I left it as is. Now I'm going to go ahead and look at my like terms. So anything that has an x, I'll highlight in pink, and anything that's just a number, I'll highlight in green here. I see that I have 2 pink like terms on this left side, so I'll keep their signs and combine them. 6x minus 3x is 3x here. I'll bring down the plus 6 I have, and it will equal to the 6 plus 3x. Now that I have like sides on opposite sides, I'll have to do the opposite operation. So to combine the 3x with the other x term on the right side, I'll have to do the opposite, which is subtract 3x. 3x minus 3x cancels out to 0x, and I bring down the number 6 that I had. Still left on that side that I haven't done anything with. 3x minus 3x also cancels out, so I know I have a special solution because I just canceled out my x's here. I bring down the 6 that I didn't do anything with on that side. Remember, when the same number equals the same number, that has to be your infinite solution case. That's what I write, and that's my answer. Next problem, we got to do our distribution first. So let's go ahead and distribute the 6 to the 2x and the negative 6 in parentheses. Distributing requires multiplication, so that's 6 times 2, which is 12. Don't forget the x. And 6 times negative 6, which is negative 36. I have to distribute the right side as well. That negative 7 goes to both terms in the parentheses. Negative 7 times negative 2 is a positive 14 with x. And negative 7 times 4 is a negative 28. From here, I'm going to highlight everything with a letter in pink and everything that's just a number in green. No pink on the same side, no green on the same side. So this is when I have to do the opposite movements here. Doesn't matter what you move over, but I'll go ahead and move over the 36. I have to do the opposite sign, so that's why it will be plus 36 on each side. Cancels out on the left side, and I get to have the 12x still there left. I'll bring it down. And then on the right side here, I'll bring down the 14x that I still have. And then I'll combine what negative 28 plus 36 is, which is going to go ahead and be 8. From here, I got to get my x's together. I want them away from my number. So I have to move the one that is on the same side as my number, which is the 14. Opposite of positive 14 is minus 14 with that x on each side. Cancels out to no x left on the right side, but I still have my number of positive 8, and it's all alone, which is good. That's my goal. Combining all the numbers together. That was that goal, and now I'm going to combine all my letters together on the other side of the equation, opposite side of the equation. 12x minus 14x comes out to negative 2x. And now I can separate the negative 2 with x by dividing. When I divide negative 2 on each side, it cancels on the left side to just x, which is what I want. And on the right side, I do 8 divided by negative 2, which is a negative 4. This is not a special case or type of solution. It's just the solution of x equals negative 4. That's called one solution because the only x value that works is when x is negative 4. In example C again, we're going to start with distribution here. I'm going to multiply the 8 to both terms in my parentheses here. 8 times 5 is 40. That will have an x. And 8 times negative 3 is negative 24. On the right side, I'll distribute the 6, which means I'll multiply it to negative 3x to make negative 18x. And 6 times negative 4 is negative 24. From here again, I'll highlight anything with a letter X in pink and anything with just a number in green here. Notice how there's no like terms on the same side. So now we got to do the opposite operation. Negative 24. Opposite is plus 24. What I do to one side, I have to do the other. It cancels out on that left side, and I bring down a 40x. And then on the right side, I'm going to go ahead and bring down my negative 18x that I didn't do anything with. And I have 24 minus 24, which also cancels out to 0. Now I got to combine my x's together. Want to move them to one side? I always like to move them to the left, so that's why I'll move the 18 over by adding 18, so that's the opposite of that negative 18. Cancels out on the right side to a 0 left, because that's 0x left, so that's just 0. And on the right side, I'll add 40 plus 18, which is 58x here. From here, I see that I have 58x equals 0. Gotta get the x by itself by dividing here. I'll divide each side by 58. Cancels out the 58 that's multiplied next to x on the left side and leaves me with just x. So x is still left, so it is one solution. And that solution is whatever 0 divided by 58 is, which is 0. 0 is a number we can have. That is a type of solution. And that is one solution because x is equal to 0. We still had an x left in the problem, so we know it's one solution of that. Next problem here, again, going to start with distribution. I will just bring down the left side, 3x minus 13, as it didn't have parentheses, and I'll leave it as is for now. But the right side, I got to distribute twice. 7 must get multiplied to the x and plus 2 inside, making it 7x plus 14. The 4, take the negative with it, has to go to both x and negative 7 inside those parentheses. By multiplication, I get negative 4x plus 28. From here, again, I'm going to color code. Anything with an x, I'll highlight in pink. And anything that's just a number without a letter, I'll highlight in green. From here, I see that I have two pink-like terms on the right side here. A 7x minus 4x. Because they're on the same side, I'll keep the same sign. 7 minus 4 is 3x. I also have two numbers on that right side, 14 and 28. I can combine those together right now to make 42 here. What I'll do is bring down my left side of 3x minus 13. Now that I've combined all like terms on the same side of that equal sign, I have to go to my opposite operations and signs to move things from one side to the other. To move my 3x to the other 3x, I'll have to subtract 3x on each side. Cancels out to 0x on the left side, and I bring down my number of negative 13. On the right side, the 3x minus 3x also cancels out to 0x. So I have 0x on each side. With no x's left on each side, I know I have a special type of solution. When I bring down the number that's left on the right side, it's 42. And I know there's no way that negative 13 will ever be equal to 42. When that's the case, I know it's my no solution case because I have no x's left in my problem and the numbers are not the same.